Welcome everyone. Today we are going to learn about Vedic multiplication techniques. Now, today we will cover some topics like doubling method, vertically and crosswise for one digit, same base method for both less and more than the base, numbers near different base, method for complementary numbers, and finally we will learn special techniques for number consisting all nines and 11. Now, I am starting with the doubling method. By the word doubling, we actually mean the multiplication of a number with 2 or making a double of any number. For this method, we will show the steps. First, we will take basic digits, that is 0 to 9. We know that any number has digits from 0 to 9. If we take say a 8 digit number, say 85341278, that also contains digits from 0 to 9. So every number we know that will contain digits from 0 to 9, and I am making two groups with the digits. The first group will contain the digits 0 to 4, and the second group will contain the digits 5 to 9. I will call the first group as group 1 and the second group as group 2. This group is basically created by checking the number of digits of 2n, where n is the digit from 0 to 9. So we know for 0 to 4, the double of each digit, that is 0 into 2, 0, 1 into 2, 2, 2 into 2, 4, 3 into 2, 6, 4 into 2, 8. From 0 to 4, the double of each digit is a single digit number. But for the latter group, it is a double digit number as 5 into 2 10, 6 into 2 12, 7 into 2 14, 8 into 2 will be 16, 9 into 2 will be 18. So there will be a two digit number and always there will be a carry 1. Now, what is the doubling method for more than one digit? Now we will start doubling from left to right of a number. Remember, usually we do it from right to left, but in Vedic mathematics, we are doing it from left to right. First, we need to make double of the leftmost digit, but we need to check for the next digit, that is the second digit. That if the next digit, that is the second digit, is from group 1 is 0 to 4, we will put down the double value directly. That is, we will put down the double value of the first digit directly. But if the next digit is from the second group, that is from 5 to 9, we will add 1 to the double of the first digit. Then we will continue the similar process for the next digits also. Now I am taking an example. Say I have asked to double this number 3, 4, 5, 6. So I will start from 3, that is the leftmost number. So double of 3, we know that is 6. But I need to check the second digit. The second digit is from group 1, so nothing to add. I am putting down the 6. Now, what is the double of 4? That is 8. But the digit after 4, that is from group 2. Remember, 5 is from group 2. Then I need to add 1 to the double of 4. Then what will happen? Double of 4 is 8 and 8 plus 1 will be 9. And then here comes 5. So what is the double of 5? That is 10. But the next digit is from group 2. Yes, then I need to add 1 with the double of 5. So if we add 1 with double of 5, that will result 5 into 2 10 plus 1, that is 11. But for the 11, the first digit, that is the first one, is already added to the double of 4, right? So I will just put the last digit of 11, that is 1. And for the 6, there is no digit more. So 6 into 12, 6 into 2 will be 12, and we will put the last 2 because Here also the first digit, that is for this case that will be 1, that is the first digit of 12 is already added to the 5 into 2. So I will just write 2. So double of 3, 4, 5, 6 is 6, 9, 1, 2. Now application of the method of doubling. So I will show you some applications of the method. The method of doubling is basically used to make some quick multiplication. As I have mentioned that we that will only check the next digit of the number, whether it is from group 1 or group 2. If it is from group 1, I will put down it immediately, and if it is from group 2, I will add 1 with the previous number. Okay, so this method of doubling is used to make some quick multiplication and calculation of some percentage also. For example, if we are asked to multiply 31 with 0.2, okay, so remember the example 31 into 0.2. Now I am explaining this. Say 31 into 0.2. 0.2. So I am just writing 0.2 as 2 by 10. So 31 into 2 by 10. So basically I need to double 31, and we know that division by 10 will result only a decimal shift. So what will be the double of 31? I can do in this method also. So what is the double of 3? We need to calculate from left. So what is the double of first digit? That is 6. And what is the next digit? That is 1. 1 is from group 1. So no need of carry. So it will be directly 6. And what is the double of 1? That is 2. There is no extra digit. So that will be 2. So 62 by 10. Now I can easily say that it is 6.2. As we know that division by 10 is basically a decimal shift. Now, the doubling method is also used to compute some percentage. For example, if we are asked to compute 20%, 40%, or 80% of a number, that is basically 1 time, 2 times, and 3 times doubling respectively. Now I am showing you the example. Say you are asked to compute 20% of 120. Now we know that for percent calculation, what we do? First, we multiply those numbers and then divide by 100. Now, now I am writing the 20 by 100 part as 120 into 2 by 10. Why? I am basically cancelling the last zeros. So what will be 120 into 2? Basically the double of 120. So again the doubling method. So from left to right we need to compute. So what is the double of 1? That is 2. And the next digit is 2. The next digit is from group 1, so no need of carry. So I will just put the 2, and then 2 into 2 will be 4. The next digit is 0. So from group 1, no need of carry again. So 2, 4, 0. And then by 10 will result a decimal shift, that is the 0 will be get cancelled, so 24. If we are asked to compute 40% of 120, then also I can repeat the same process. Why? Because 40% of 120 is basically 120 into 40 by 100. So 120 into 2 into 2 by 10. I am repeating that it will be 120 into 4 by 10, and I am writing the 4 as 2 into 2. So it is basically dual doubling. So how can we do dual doubling? The same method as we have doubled. So I will first double 120, and then I will make the double of 120. So first I need to compute 120 into 2. We know that that will be 240 from the previous example. And then I will compute 240 into 2. That will be in a similar process. So here also 2 into 2 will be 4. The next digit is from group 1. So there will be no carry. 4. Similarly, 4 into 2 will be 8. The next digit is 0 from group 1. That will be no carry. So 480. Okay. Here I need to give a by 10 for percentage calculation. Remember to divide by 100 actually. So here will be 48. For 80% also we need to double thrice. Now I am entering in a new method, that is vertically and crosswise multiplication for one digit. Now, for one digit multiplication, I am taking the base method again. First, we need to take the number 10 as a base. Remember the number 10 as a base, no sub base of 10. I am just taking the number 10 as a base. At the next step, we need to compute the difference of the number we have chosen with the base. That means if the number is n, the difference will be 10 minus n. Right. So at the step 3, we will write down the differences beside the number with proper sign. For one digit, we know that every number will be less than 10. So there will be minus sign. And usually if our number is less than the base, we will denote it as n deficiency. What is n deficiency? N is basically base minus the number. For one digit, will all will be the deficient because 0 to 9 is less than 10. Now we will cross subtract to get the first digit of our answer, which means subtracting the deficiency of the first number from the second and subtracting the deficiency of the second number from the first. Remember, here we are doing the cross subtraction. Don't do the direct subtraction. Here we need to do the cross subtraction. That means subtracting the deficiency of second number from first and vice versa. Now, we will multiply the deficiencies to get the last digit. If the multiplication result in one digit number, then we will put that as the last digit of our result. If the multiplication result in two digit, then we will carry the first digit and will add to the first digit of the actual result that we have obtained from cross subtraction at step 3. Now I am showing you some examples. Okay, I am asked to do a simple multiplication of one digit, that is 5 into 6. So 5 is basically 5 deficiency because 10 minus 5 will be 5. So I am writing the deficiency with proper sign here. So 5 minus 5. And then 6 will be minus 4. Why 6 will be minus 4? I am just, for better understanding, I am putting in a bracket because this is not the actual subtraction. Okay. This is the deficiencies. Now I need to compute the first digit of our result. How I can compute the first digit of my result? That is the cross subtraction. So I need to subtract 4 from 5, not minus 4. Actually, I am taking the proper sign to understand what will be the last digit or what will be the sign of the last digit of the answer. So here I need to just subtract the mod value or the modular value or the positive value of the deficiency from the first number and positive value of the deficiency of first number from the second number. So our first digit will be, what will be our first digit? That will be 5 minus 4, 1. Or similarly, I can do the reverse way also. That is, from second I am subtracting the first. That will be result 6 minus 5. That is 1. Now remember the first digit will be 1, but for the last digit calculation, that is the second digit calculation, I need to multiply the deficiencies. Now the second digit will be, here I need to multiply with proper sign. So here the sign is actually required. So minus 5 into minus 4 will result in plus 20. Now, as we know that multiplication of two one digit number can only contain two digit max, because the maximum number is 9 into 9, that will be 81, we know that. So the maximum it will be two digits, so the last digit can be formed from the last digit of 20. So the actual last digit is 0, that is the last digit of 20. And what will be the first digit? We got the first digit from our calculation was 1, but remember we have a carry, at 20. The carry here is 2, so the 2 or the carry must be added to the first number. So our first digit will be 1, what we have got, and our carry, that is 3. So the result is 30. Yes, 5 into 6, that is 30, we know that. Now, I am getting the same thing for a bigger number, and I will show you some examples of the same process for bigger numbers. The same base method, both numbers are more than the base. Say I am taking an example, say as we have previously mentioned, the bases can be 10, 100, 1000. Say I am taking the examples of say just 10 base. Then the numbers above the base will be like 11, 12, 13, 14, 15. So when we are multiplying those numbers, we need to check the method. When both the numbers are close but more than a same base. Okay, then we will follow the same steps as we have mentioned in previous example, but here as our numbers are more than the base, remember I am taking the numbers more than the base, so we will call the difference as surplus, because here there will be no deficiency. We will call it as surplus, and we will do cross addition instead of cross subtraction. Okay, so in the previous step we have done cross subtraction, but here we will do cross addition. Now let me take a simple example of it. Say 112 multiplied by 125. Now what is 112? That is plus 12 for 100 base, because I am taking the base as 100 here. Now for similarly 125 it will be plus 25. Now what we need to do for the first part, we need to cross add. Remember here we won't do the cross subtraction. We will do cross addition here. So by cross addition, we get the first part of our answer as, so what is the cross addition procedure? 112 is the first number that will be added to the surplus of 125. So that will result in 137, and similarly the 125 will be added to the surplus of 112, that will also result in the same. So in both cases the result will be same, this is guaranteed. Now the last part of our answer will be 25 into, sorry, here I need to check for the digit also, sorry, the sign also. So plus 25 into plus 12. So here I have 300, but can I just put the 300 directly? No. Why I can't put the 300 directly? Because here I can only I can allow two digits only from the rightmost side. Why? Base because the base contains two zeros basically. So I need to compute how many zeros the base have, and I will keep the digits, the same number of digits, and then I will carry forward the remaining part. So what will be the last two digits of 300? That is 00, and I will carry forward the 3. So the carry forwarded 3 will be added to the 137 part. So the actual first part will be first part after adding carry will be 137 plus 3 as a carry. So it will be 140, and the last digits was 0 and 0. The last digit was 0 0. So the answer is 14000. So this method is very simple, but you need to remember some things like what is surplus, what is deficiency, and where we can do cross subtraction, and where in special cases where we can do cross additions. So you need to remember a few things like this. But this method is very easy and very quick method also for multiplication. Now, the same base method, both numbers are less than the base. Now, what will happen for the numbers which are less than the base? Here we will follow exactly the same method as we have followed for vertically and crosswise multiplication for one digit. Because when we are doing with the vertically and crosswise multiplication for one digit, remember one thing, there was all digits with deficiency, right? So 0 to 1, 0 1 2 3, all were deficient numbers. Up to 9, all were deficient numbers. So if I have mentioned that the taken numbers are less than the base, so I can directly say there will be deficient case only. Now, I am just showing you another example, that is, say I am taking a simple multiplication, that is 78, say, cross 86. So what is 78? 78 is, remember here, for 100 base, it is minus 22, because 100 minus 78 is 22. Then 86 will result in 100 minus 86, that is 14. So what will happen here? Here I need to do cross subtraction, but remember, the cross subtraction does not mean the subtraction with sign. So I just need to subtract 14 from 78, not minus 14. I just need to subtract 14 from 78. So the first part, or the obtained first part, basically not actual, but because we may have some carry later on. So the first part we have obtained is either we can write it as 78 minus 14, that is 64, and also you can mention it as 86 minus 12, whatever we can do that. So the first part we have obtained is 64, but for the second part we need to multiply. Okay, so we need to multiply the deficiencies. So the obtained second part will be minus 22 into minus 14. So I just need to multiply these things. For bigger multiplication, I can also do it as uh, the vertical method also, or any other method you can do that. So for 22 into 14, that will result in 308. So is the 30 will be directly put down? No. Then I need to put down the last two digits of 308. And what will be the carry here? Yes, the first digit of 308. So the carry here will be 3. So I will add the carry with the first part to obtain the actual first part. The actual first part after adding carry will be 64 plus 3, that is 67. And the last part, that is basically the last two digits of 308. So that will be 0 and 8. So the total answer will be 6708. And if I have given a large multiplication, say I am taking say 187 into 198. Say. So what is 187? Okay, so let me take not like this, because 187 is the near about 100. So I am taking a number which is near about but less than, say, 1000. Okay, so I am taking the number as 998 and 987. So what is 998? 998 is basically minus 02, like this 002, because the base here is 1000. So what is 987? 987 is basically minus 013. Now I need to do the cross subtraction for the first part of our answer. So what will be the result of cross subtraction? We need to check. That is, the first part of our answer will be 998 minus 13, or 987 minus 2. For both cases, that will result 985. I repeat, the cases here are similar. Now I need to multiply the bases, sorry, the deficiencies. I need to multiply the deficiencies. So the last part will be minus 02. Sorry, it will be minus 002. And then it will be, remember one thing, that in this case, I need to consider the signs. So it may have some extra zeros, but remember one thing, that I need to compute the zeros of the nearest base. So what is the nearest base? That is 1000. So how many zeros are there in 1000? That is 3. So I can only keep 3 digits from the last part, from the obtained last part. So I am taking the last 3 digits only. So the last 3 digits will be 026, because the actual result will be, say, 0026 or 00026 something. So I am just taking the last 3 digits of the obtained multiplication of deficiency. So the actual result here, I think no carry will be there, because I am just taking the last 3 digits. And for the previous digits, that was 0, so there was no carry. So the actual result is 985,026. So for bigger multiplication also, I can do in this way. Now, different base method, both numbers are more than the base. Okay, so I am just a bit advanced with the method, so just I am introducing you to the different base method. So this is a bit advanced method. First, we need to take the nearest multiple of 10, or for making easier, we will take the nearest power of 10. Say for some example, say you are taking bases as 200, 300, 400, but I will recommend you that when you are doing bigger multiplication, take the basis as power of 10. Say 100, 1000, 10,000, like that. Okay. So that will be very helpful for your calculation. Now we need to compute the difference of the number we have chosen with the base. Similarly, we will write down the differences beside the numbers with proper sign. Usually, if our number is more than the base, I repeat that we will denote it as a surplus, and if that is deficient, I will write it as deficiency. Then, for this particular method, I will ignore the last digit of the bigger number. But why I am ignoring the last digit of the bigger number? Because we know that for the smaller number, the base is different. So when I am multiplying a number which is not in the same base, I need to adjust the number of digits, because the number of digits is very important. Because when we in the previous example, when we were taking the carries, what we have done, that is, we are taking some number of digits and then we are taking the remaining number as a carry. So if we can't compute what is the actual number of digits we need to take as a carry, or we need to take as a put down number, so we can't do the method until we can learn about this. So then we will ignore. So for that purpose, we are ignoring the last digit of the bigger number, uh, just to similarize the bigger number as the similar number, and add the remaining part with the surplus for the smaller number to get the first part of our answer. Okay. Now, then we will multiply the surpluses for both the number to get the actual answer. Now I am taking an example that will be very helpful for you. Say I am taking a simple example, say 1122 and multiplied by 104. Say. Now what will happen for 1122? We know that here the nearest base is 1000. I remember one thing, that you can take the nearest base as 1100 or say 1200 also, but I am taking the power of 10 to making the to make the calculation easier only. Okay. So what is 1122? That is plus 122 for 1000 base. And what is 104? That is plus 04 for 100 base. Now, what we can do? The cross addition. Okay. So we need to do the cross addition, as we have mentioned that when we are getting the surpluses, we need to do cross addition. Now, as I have mentioned that we need to remain off the last digit. Okay. So I am just making the last digit with a bracket to make it off. Okay. So what will be the actual answer? So 112 only, that will be added to 04. Okay. Then the first part of our answer will be 116. In this case, the latter part, that is the cross check part, that is the 104 plus 112 is the usual method, but sorry, here the surplus is 122, so 104 plus 122 must be added, but here also we will take the last digit of the surplus off. So what will be the actual result? So here the actual result will be 104 plus 12, so 116. So both the cases I am getting the first part as 1, 1 and 6. Remember one thing, that the surplus of bigger number must be reduced to the 3 digit, because I am here to similarize two numbers. Okay, so the first part is 116, but what will be the last part? The last part will contain the vertical multiplication, or similarly the multiplication of the surpluses. So What was the surplus of first number? That was 122, and the surplus of the latter number is 04. So the last part for the obtained will be 122 cross 04. That is 488. But we need to remember one thing, that whether we are getting 488 does not matter, but here I need to keep only two digits, so 88 will be kept and the 4 will be acted as carry. Remember one thing, as I have mentioned, that first part, when we were adding the first part, we were taking the last digit as a off, but we can't actually off the last digit, so I need to remember the step, at the last step I need to regain the last digit what I have mentioned as a off. So here also last digit is regained. So the number is basically 1162. Okay, so remember I am doing the actual addition with the last digit off, but when I am checking the final calculation, I am regaining the last digit. Okay, so here will be also 1162. Now the first part will be 1162. At the last step, we are taking the first part as 1162, because at the last step, I am taking the last digit what we have mentioned as of again. Now, the actual first part will be 1162 plus 4. Why? Because the last part is 488, then two digits will be there, and the first four will be treated as a carry. Now, here the carry is 4. Remember one thing, that the first digit of 488 will be treated as a carry. Now, the actual first part will be 1162 plus 4, that is 1166. So, the answer will be 1166 and 88, because for 488, the last two digits will be retained. Now, different base method for both numbers which are less than the base. In this case also, the similar method will be followed. The exactly similar method will be followed. We will ignore the last digit of the bigger number, and here I need to cross multiplication for the last digits of the number. Now, now if I have given another case, that is one particular number for the same base case, I am not going for the different base. For the same base case, if I have given that one number will be above the base and one number will be below the base, then what can be done with this scenario? Okay, so remember one thing, that I am taking the same base, but one number is more than the base and one number is less than the base. So we need to compute the difference from the base at the first step. In this case, one will give surplus, that is, the more than the base will give surplus, and another, which is less than the base, will give us deficiency. So there will be one plus line and there will be one minus line. As we have mentioned, that we need to write the surplus or deficiency with proper sign. Remember one thing, from the first step, I am mentioning it repeatedly, that we need to write the deficiency or surplus with proper sign. Because when we are calculating the last digit, the proper sign is one of the most important calculation part. We know that here the multiplication with the surplus and the deficiency will give us a negative integer. Why? Because say I am uh, just taking a basic example. Say for base 10, one number is 13 and one number is 7. So what is 13? 13 is 3 surplus. That means plus 3. Yes, because 13 is 10 plus 3. So I am writing the surplus as plus 3. But for 7, what will happen? That is minus 3. So a surplus multiplied by a deficiency will result a negative. That is a deficiency basically. In this method, I have another trick. That is the first digit are calculation in the same way. The same way as I have mentioned that cross addition or cross subtraction. But here surplus of the bigger number is added to the smaller number. Why? Because I know that for surplus case we usually do the addition, and for the deficient case we usually subtract the deficient. But here I have both. So what can be done in this scenario? The surplus of the bigger number is added to the smaller number, and the deficiency of the smaller number is subtracted from the bigger number. Okay, so that will be very helpful to get the first part of our answer. So let me take an example of it. Then, what is step 4? At step 4, I need to write the nearest sub base of our answer, and we need to subtract the negative part from the sub base to get the actual answer. So let me take an example of it. Say I have given 105 into 98. Say. So both cases the base will be 100. So for 105 it will be plus 5. For 98 it is 2 with a negative sign. Now what can be done with the first part of our answer? We know that for the first part of our answer, we will proceed with a similar procedure as I have mentioned in the previous steps. So 105 minus 2 will be there, and 98 will be added to the surplus, that is 5. So here I need to answer it as 98 plus 5 or 105 minus 2. The both cases it will result as 103. But as we have mentioned that here I need to consider the sub bases also. Okay, so I am not going to the direct sub base calculation, but first I am getting the last part of our answer. So the last part of our answer will be treated as the, remember, with proper sign must be added. So plus 5 into minus 2, that is minus 10. So the actual multiplied deficiency is minus 10. So then what is the step 4? I need to compute the sub base including the first part. So what will be the sub base including the first part? And remember one thing, that it will result in 5 digits. So I need to compute the 5 digit surplus, the 5 digit sub base. Now what will be the 5 digit sub base containing 103 as the first part? That will be 10300. That is the very simple method. And then I need to subtract the 10, because 5 into 2 with a negative sign is basically giving us the minus 10. So I will subtract the minus. I remember the thing that surplus into deficiency will give you a deficiency, and we need to subtract the deficiency from a sub base for which the number of digits will be 5, or say the number of digits is basically the number of digits of our desired result. So the number of digits of the sub base will equal to the number of digits of our desired result, but it will contain the obtained first part that we have obtained from the cross addition or cross multiply cross subtraction, that will contain the first part as the base. So 10300 will be the subbase and the result will be 10290. So in this way also I can do this method. Now, when one number is above and one number is below with a different base. In this way, I have two procedure. Okay. We need to compute the difference as similarly. I know that here also a deficiency and a surplus will give us deficiency. The only difference of the method is that we need to adjust the bigger number and the smaller number with the corresponding difference to match digits. But how we can do that? Okay, so let me take the way I am doing this thing. I am taking an example 1035 into 976. So what is the first number, that is 1035 is basically 35 surplus of base 1000. Just writing the base for better understanding. Here base is equal to 1000. But for 97, 97 is basically 3 deficient, but the base is here 100. But we need to adjust the bases. Whether we can adjust it or not, that will define the actual multiplication. So what can be done with 97? So just I am putting a trick here. So let me put the trick 1035 and then I am writing 97 as 970 by 10. I am just putting it in a bracket 1035 into 970 by 10. Then 970 is basically a 30 deficient from 1000 base. So 1035 and 970 is basically near about the same base. And I have mentioned for the same base that the method was the previously mentioned method. I just copy the method for this time also. So 1035 is I have mentioned that plus 35. And now I can safely write 970 as minus 30. So when I am putting the similar base, then the method will be exactly same like I have mentioned in the previous case. For the previous case, that was the two numbers, one was above than the same base and one was below than the same base. For this case also, there was no same base. There was different base. But I am taking by multiplying it by 10 and later dividing by 10, I am taking the different base as same base. So I can do that because I have the right to multiply it by 10 and then divide it by 10. That will not affect our actual result. Now it is easier for us to compute. Now the first part will be 1035 minus 30. So that will result in 1005. And the second part will be 970 plus 35. Remember one thing, that we need to add the surplus and we need to subtract the deficiency. So 1005 will be there. Okay. So the similar answer we will get because we know that the similar answer is very common. Now, what will be the last part of our answer? The last part of our answer will contain the multiplication of the surplus with, we know that the multiplication of the surplus, so 35 into deficiency, that is 30. So what will be 35 into 30? that is 1050. But remember one thing, in this case, I need to put the last zero off. Why? Because I have mentioned that it is basically a multiplication by 10. So when I am multiplying by 10, I need to compute the last zero as a off. Okay. Now the method will be similar. So what is the nearest base? 1005, and there will be another two numbers. Okay. So I am subtracting the multiplication from nearest sub base. So the result will be 100395. Remember one thing, that the nearest sub base will contain the obtained first part as its first part. So this is very simple. Say if our obtained first part is say ABC, then the nearest sub base will be ABC00 or ABC000, or the number of zero is actually required. Okay. So the in this way the sub base can be calculated in very simple way. Now this method is very quick. Now method of complementary numbers. In these cases, I am considering a particular pattern. Which pattern? That I have given two numbers. The numbers whose first digits are same, but whose last digit will add up to 10, 100, etc. That means, say 44 and 46. The first digit of both are 4, and whose last digits are 6 and 4, and add 6 plus 4, that is 10. So in these cases 44 and 46 are called complementary numbers. Now how to multiply complementary numbers? To multiply two complementary numbers, we just need to follow some simple steps. We will multiply the last digit of both numbers to obtain the last part of our result. So for 44 into 46, what will be the last part of our result? The last digits, remember 4 into 6 will be there. So our last part of our result will be 4 into 6, that is 24. But we will then multiply the first digit of each number. The first digit of each number here same with the next consecutive number to get the first part of our answer. So what is the next consecutive number of 4? That is 5. So the first part will be 4 into 5, that is 20. So the first part will result in 20 and the latter part was 24. So the actual result of 44 into 46 will be 202. Now I am coming to the method for complementary numbers. The complementary numbers are actually the numbers whose first digits are same and whose last digits add up to 10, 100, etc. Now, method for complementary numbers. To multiply two complementary numbers, we just need to follow some simple steps. We will multiply the last digit of both numbers to obtain the last part of our result. And then we will then multiply the first digit of each number. Here the first digits are same with its next consecutive number to get the first part of our answer. Now, let me take some examples of complementary method. Let me take a simple example, that is 53 into 57. The last part will be 7 into 3, as I have mentioned that 53 and 57 is complementary. because the first digit here is 5 for both, and the last two digits 3 plus 7 add up to 10. Now, the last part of 53 into 57 will be 7 into 3, that is 21. And the first part will be 5 into 5 plus 1. Why 5 plus 1? Because I have mentioned that we need to take the next consecutive integer for multiplication. Then 5 into 6 will be there. So the first part will be 30. So the total answer will be 3, 0, 2 and 1. Now let me take another bigger example. Say 143 into 157. As I have mentioned that not always I need to check for 10. It may happen that the addition of last two digits is resulting in 100. Then also I can say the complementary using the criteria, that is the first digit was same. So here also the first digit is same, that is 1, and the last two digits is 43 and 57 add up to 100. Now the last part from our method will be 43 into 57, that is 2, 4, 5 and 1. The first part will be 1 into 2. Why 1 into 2? Because the next consecutive integer of 1 is 2. Then the multiplication will be 2, 2, 4, 5, 1. Okay. Now, multiplication by consisting of all nines. To multiply an arbitrary number with a number consisting all nines, then three cases will arise. For case 1, when number of nines in the multiplier is same as the number of digits in the multiplicand. What is multiplicand? The multiplicand here is the non-9 number, that is the arbitrary number what I have taken, and multiplier is the number containing all nines. Maybe it maybe 9 or 99 or 999, whatever. Now, in the first step, when the number of nines in the multiplier is same as the number of digit in the multiplicand, we need to reduce the multiplicand, yeah, the number which is not all 9 by 1. Okay. So if there is 16, I need to put it as 16 minus 1, that is 15. Okay. Then we need to apply the all from 9 but the last from 10 method on the number which is not all nines. So let me take example of it. So the 23 into 99. So here all 9 number is 99 and the arbitrary number is 23. Now the first of all here digits are same. So I will reduce 23 by 1. So the first part will be 23 minus 1, that is 22. And now I need to apply all from 9 but the last from 10 method to 23. Now applying all from 9 and last from 10 method, remember the all digits except the last digit will be subtracted from 9 and the last digit will be subtracted from 10. So here 2 will be subtracted from 9 and 3 will be subtracted from 10. So subtracting 2 from 9 will give us 7 and subtracting 3 from 10 will give us 7. So the actual result here is 2277. You can easily verify this result. Now, case 2. Case 2 is when nines in the multiplier are more than the multiplicand. Okay, so arbitrary number has less digit than the our taken number. So in this case, we need to follow these steps, that we need to put 0 as the left side of the multiplicand to match the digit for both numbers. Okay, so I need to put a 0. Then we will follow the same steps as case 1. Say I have given a number, say 78 into 999. So for 78, I need to put a 0 left hand side. So it will be 078, then 999. Now the digits are same. So the previous method will be repeated. So now the first part will be remember here I have put a 0, so you can put the 0 also, 077, and the last part will be applying all from 9 but last from 10 on 077. So apply this. So 0 will be subtracted from 9. So 0 will be subtracted from 9 will give us 9. Then 7 will be subtracted from 9, that will also give us 9. And then 2. Then the total answer will be, then the total answer will be 77922. Now when nines in multiplier are less than the multiplicand, then we will divide the number which is not all nines into two parts, and the last part will contain the same number of digits that the all nine number has. Okay, then we need to add 1 to the first part and subtract the sum of the total number to get the first part of our result. So let me explain this thing. This thing is a bit complicated. For this method, what I am doing, that is, say I have given 537 into 99. Okay, then what can be done, that is I need to divide 537 in two parts. So what is the number of digit in 99? That is 2. So the latter part will contain 2 digits and the first part will contain 1 digit. So the parts will be 5 and 37. Okay. Now we will follow the similar step, that is we need to multiply the first part, sorry, we need to add 1 to the first part, that is 5 plus 1 is 6. And then the sum, that is what we have what we have got after adding 1 to the first part, that is to be subtracted from the total first part, that is 537 minus 6. Then that will result in 531. And for the last part, we will do the all from 9 but last from 10 method for the next part, that is 37. So remember one thing, that for the first part I am subtracting 6 from 537, and for the next part I am taking the all from 9 but the last from 10 method on 37, which was the next divided part of the 537. Now after putting that, that will be 3 will be subtracted from 9 and 7 will be subtracted from 10, that will result in 63. Now the total answer will be 53163. This is as simple as this. For Vedic mathematics, to multiply a number by 11, we just need to do some three simple steps. That is, write the first digit of the number to get the first digit of our result. So the first digit of our number will be the first digit of our result, and the last digit of our number to get the last digit of our result. But remember, there will be a middle digit containing the sum of the two digits of the number. So what is the actual process? Say 35 when it is multiplied by 11. Say, I just need to put 3 as the first digit of the number will be the first digit of our result. Then the middle digit will be 3 plus 5, that is the sum of the digits, and the latter part will be the last digit of the non-11 number will be the last digit of our result. So The actual result will be 385. So for 21 into 11, 2 will be the first digit, then 2 plus 1 will be the 2 plus 1 will be the middle digit, and then 1 will be the last digit. So 231 will be the answer. So nothing to do with 11. Just putting the number, I can say the answer for 11. Now, general method of multiplication. For all the previous cases, I have mentioned for some particular things. But now I am mentioning the general method for multiplication. Now, first of all, I will repeat for it for 3 digits, and now uh, I am doing it for 2 digits. Now, here we will denote 2 digits of the number as A and B for one number and C and D for another number. So if we are asked to multiply 53 into 47, what will be our A and B? Say I am taking 53 as the first number, then A will be 5, B will be 3. And for C, it will be 4 and D will be 7. That is for 47, I am dividing it as 4 and 7. Okay. Then we will compute 3 parts. Remember, here the parts means multiplication. So B into D, that is BD. A into C, that is AC. And AD plus BC part. Okay. Now we will write sequentially AC, AD plus BC, and then BD part. The BD part will give us the last digit of our answer. If it's a 2 digit, then we need to carry forward the first digit and add to the next part, that is AD plus BC, and again the same step will be followed. Okay, so I am writing the thing. So what are the part? AC, AD plus BC, BD. So what are the parts? AC, AD plus BC, and then BD. Now, as I have mentioned in the example, that is not the actual summation partition. It is just a partition. But we will use to compute our final result. So say 53 into 47, as I have mentioned here, A is, what is the value of A here? A is 5, then B is 3, C will be 4, what will be D? D will be 7. Now, what will be the AC part? AC means A into C. So A into C will be 20, 5 into 4. Now, A into D plus B into C. A into D, that means 5 into 7, that is 35. Plus B into C. B into C means 3 into 4, that is 12. And then B into D. B means 3, D means 7. So B into D means 3 into 7, that is 21. So the result will be 20 slash 47 slash 21. Now how to compute the actual result? I have mentioned the thing that we need to put down the last digit of the last part as our last digit of the final. So the final last digit will be 1, and then 2 will be carried forwarded and added to the latter part, that is 2 will be added to the 47 part. So 2 is the carry of 21 that will be added to 47 part to give us 49. So what will be the next digit? That is 9, because the last digit of 49 will be put down. So the next digit will be 9. Remember, this is a reverse order. Okay, not the next digit means the next last digit. Okay, so the next digit from right side, better understanding, I am writing this, mentioning the side, will be 9. And then 4 will be carried forwarded to 20. Here there is no more part, so 20 will be added to 4. So the answer will be how much? 2491, because I am taking the reverse order. Okay, so 20 will be added to 4 to get the first part of our answer, then reverse way 2491 will be there. Now, I can extend the method for 3 digits also. For 3 digits, remember one thing, that there won't be AB, here it will be ABC, and the latter part will be DEF. And what will be the parts? Here the parts are a bit complicated. Okay, so we need to remember one thing, that when I am doing the parts, so the parts should be mentioned clearly and should be uh, do with a correct solution. Now, say I am just doing a bit complex example, so 345 into 234. Okay. Now, what will be the sequential part? The first, it will be AD. There will be AD. Then AE plus BD. Remember, we need to do it sequentially, otherwise we won't get the correct answer. Then A plus B plus CD. Then BF plus CE, BF plus CE, and then CF. What is A here? I am mentioning all digits. A is 3, B is 4. Remember, this is just digit breaking. So C will be 5. Again, D will be 2. E will be 3. And F will be 4. Now, AD will be 3 into 2, that is 6. Then AE plus BD. What is AE? 3 into 3, that is 9. Plus BD will be 4 into 2, that is 8. Now AF will be 3 into 4, that is 12. Then B will be 4 into 3, that is also 12. And then CD will be there, so CD is 5 into 2, that is 10. Now BF plus C, so what will be BF? That is 16. C will be there, so C is 5 into 3, that is 15. Now CF will be there, so CF will be C is 5 and F is 4, so that will be 5 into 4, 20. So I am just rewriting the parts. 6, 17 will be there, then 34 will be there, then 31 will be there with a partition. Remember one thing, that all things will be done with a partition. Now the last digit will be 0, because the last digit of 20 is 0. So the last digit is 0. And the next digit from right, is the carry will be added to 31. So 2 carry 2 will be added to 31 to give us 33. So the last digit of 33 is 3. Again, the first digit of 33 will be carried. So 3 will be added to 34. So 37 will be there. So the last digit of 37 is 7. Okay. So the third digit from right will be the last digit of 34 plus 3, that is 37. That is the last digit of 37 will be 7. And then the first digit of 37, that is 3, will be carried forwarded and added to 17, the next part. So adding 17 with 3 will give us 20. So the fourth digit from right will be the last digit of 20, that is 0. And then 2 will be carried forwarded to add with 6. So the first digit or the leftmost digit will be, or the first digit from left actually. Okay, because I have mentioned from right, so I am just mentioning it from left here. So the first digit will be 6 plus 2, that is 8, because here is no carry. So in reverse order we need to compute. So the actual result is 8, then 0, then there will be 7, then there will be 3 and 0. So 80730 will be the correct answer. So in this method, we can do the multiplication in very quick way. But remember one thing, that the partition should be made clearly and correctly, because the sequential approach of the partition is very important. Either you can do it by sequential approach or you can do it by base method. That's nothing matters. But when you are doing this method, remember to arrange this in this particular sequence. If you put A plus BD instead of BF plus C in fourth part, the result will be reversed, or the result will be the wrong result. Okay. So for the correct answer, I need to put in this sequential order. So remember one thing, the sequential order must be reminded. So in this way, we can do many things with Vedic multiplications. Now method for algebraic expression. For multiplication of algebraic expression, consider the parts as digits and follow the same process as previously mentioned for vertical and crosswise. Now let me take an example. Let me take an example of it. Say I have mentioned x plus 1 with x plus 3. Then what can be done from the vertical method? We know that we have written x plus 1 under which we have written x plus 3. Then by vertical method, what we have done, that is we need to cross multiplication. Okay, we need to cross multiply the thing. So here I will cross multiply first and then I will add the digits with it. Now after cross multiplication, what will be the result? So the first part of our answer will be the multiplication of first digit with its first digit. So the first part our answer will be x square, because the first digit with the first digit multiplied by the first digit will result in the x square, because x is here multiplied with x. Now for the middle part we will use the vertical method. Now what is the cross multiplication here? X will be multiplied with 3 and then 1 will be multiplied with x and it is added. So the middle part will be 4x and then 1 into 3. So the expression will be x square plus 4x plus 3. You can do this thing with the previously mentioned partition method also, or some partitions should be made with a square plus, I mean, if we are mentioning the x as a and 1 as b, and then c as the next x and d as the next 3, then what will happen? The first part will be a into c, because x into x will be there. The last part will be b into d, because 1 into 3 will be there, and the middle part will be a into d plus b into c, because the cross multiplication will be there. So by this method you can do this thing also, by partition method. So thank you for seeing this video. I hope this will help to learn some quick techniques of multiplication. Thank you.